When you think of military vehicles, what do you see? You don't see oil, hydraulic fluid, coolant? Maybe you should look again.
Fluid is the lifeblood of any equipment, aircraft as an example. Hydraulic fluid keeps the flight controls working. Oil and other oil-wetted fluids keep our components cool and operating sufficiently. Without that in our airframes, our aircraft don't fly. It's just that simple. Let's say, for example, we have an issue where we think that we have contamination.
Dirt, soot, sand, glycol, soil, water. Sometimes it gets contaminated because somebody put the wrong stuff into the container. You wouldn't believe how many times the Defense Department has put the wrong fluid into things. Not just hydraulic fluid into engine oil, but also even floor stripper.
The current system that we have at our disposal is to first pull a sample from the field. You package a sample at the field. You ship the sample to a laboratory. The laboratory conducts laboratory analysis. The analysis is then turned around and given back to the field. Now, those steps take time, they take money, and they have a degraded impact on readiness.
Fluid sampling and fluid measurement in laboratories is not convenient, it's not cost effective, and what we need to do is make it cost effective. And how are we going to do that? We're going to do that by creating a portable or handheld fluid assessment device. And so our goal here with this project is to create something so that the end user, the maintainer, can evaluate fluid quality in his assets and make a decision as to what you need to do about that fluid. Do you need to take a maintenance action or not?
What we've done is miniaturize current lab instruments, and we've created this handheld portable oil assessment tool so that it weighs approximately 5 pounds. Our warfighters can hold it in one hand, take 1 drop of oil, and be able to get the same results that they would get from the lab.
The instrument is very portable, and that's the best aspect of it all. It can be used out in the field. There's the end user can have it with them. You can have it in their vehicle. You can have it on their aircraft. It's very user friendly, and it's very easy to train on. So anybody in the field can be trained on it in a matter of minutes.
This project started with a focus on ground equipment. And in fact, that's been an issue with ground equipment in general, which is viewed largely as expendable in many ways because flight safety does not apply to ground equipment. Instead, the only way to get benefits of those assets, out of testing those assets, is to reduce the cost of testing. If the cost of testing right now and sending a sample to a laboratory is $3, then $3 is too high because we're not getting that money back. But if we could reduce that to a quarter or a dime, that changes the whole cost-benefit equation, and it's expanded to include air equipment. Now, where are we going with this? We're going with the idea that a handheld unit is very advantageous to us. Why? Because it reduces the cost of testing assets that we cannot otherwise afford to test.
I guess the real issue is this. This particular device could give a go, this is a good sample, or no go, this is not a good sample in minutes. And it gives that soldier, that sailor, that airman, the Marine in the field, the user who's really actually trying to complete a mission, a particular situation, and say, yes, we can carry on with this mission, or no, we have to take some kind of other action.
One of the difficulties in fluid assessment is that the government has to balance the cost of testing the fluid, the cost of sending it to a laboratory, with the cost of saving equipment or reducing maintenance. And that balancing is difficult to achieve.
We know that testing oil in the lab is an expense. It can be very expensive. But if we had a handheld device that we could actually test on the spot, that would reduce all those costs. Our whole goal is to keep our planes in the air. And we do that by condition-based maintenance.
The idea of condition-based maintenance is you don't take any action until action is required. For example, you don't change the oil until the oil is bad. We're extending the life of the equipment. We're changing the oil based on need actual need versus calendar time, which ultimately ties into condition-based maintenance.
Fluids is really all-encompassing. It's not just lubricant, although lubricant certainly is a large part of it. It's mineral oils, it's hydraulic fluids, it's synthetic aircraft fluids.
The primary benefit of this device to the military is providing real-time, at the point of use, fluid assessment for critical assets. It increases the readiness, it allows the warfighter to concentrate on what they need to do for their job as opposed to worrying about taking samples and sending them off to the labs and waiting for results.
There's a real need to maintain legacy systems because there's a tremendous amount of equipment that has been in the field for a number of years and will continue to stay in the field for at least 15 years. It is very critical that we maintain these systems. That is a main emphasis on the CTMA program. We focus on maintaining legacy systems.
This instrument was developed through funding under the Commercial Technologies for Maintenance Activities program. Now, the CTMA program is a special program funded by the Pentagon through the National Center for Manufacturing Sciences to help develop commercial technology specifically for maintenance activities. It's to help give things the extra push so that the military or the Defense Department can use things that already exist, but apply them and adjust them and adapt them so that they meet a military need.
This project has been running for about a year. We're currently in phase 2. We have handheld devices that are being field tested. Our project is currently working on expanded capabilities such as viscosity sensor, particle count capability, as well as wear debris analysis.
I think the potential benefit of fielding a device such as this portable handheld has the #1 benefit of improving readiness, improving safety, and reducing cost. Those 3 elements are the DoD goals. Readiness is the availability of our assets to do a mission. That's what readiness is, in simplest terms. Without readiness, that soldier, that airman, that Marine, that sailor, those people that we put out there in harm's way are not able to complete their mission, or sometimes they'll have to complete a mission and not in the safest means available.
Our project is very exciting because we know that we can make an impact with our warfighters. The Marines love it. We know the Army loves it. We're talking to the Navy right now, and we have folks in the Air Force. They're really excited about using our new device.
Wrong fluid, if not detected, water, for example, in a hydraulic system, can completely shut down that hydraulic system and cause a catastrophic failure. That means we lose people and equipment. A device like this potentially can contribute to safety across the board when used effectively. That's important. We are giving the user, the person in the field trying to complete a mission, an opportunity to make a decision with a reliable, repeatable, good instrument so that we can carry on the fight.